Hi folks, in today's video we're going to be going through time series machine learning techniques, starting with the basics and going to some more advanced techniques. The contest we're going to be using is a Kaggle, getting started contest. I use air quotes there because I feel that this contest is a bit more advanced. Well, at least to get to the top of the leaderboard is more advanced. You can do basic techniques here and get a reasonably good result, but then there's a big gap between doing that and getting to the top of the leaderboard. So without further ado, let's just jump right into what we want to talk about today. So this is the contest. Don't worry, all the links will be in the description below, as well as chapter bookmarks. So feel free to jump around if you are to whatever is interesting to you. So basically, in this contest, there's a grocery store from Estonia, and you have to predict grocery store sales. And you have to predict them 15 days in advance. So you're not just trying to predict tomorrow; you're trying to predict what's going to happen over the next half of the month. Let's just look at the data. Actually, you know what? Actually, we can just go to my notebook where it goes through EDA. We can just skip that. Oops. Actually, sorry. Yeah, first I want to talk about the lesson section here. If you have no experience with time series and some of this is a little bit over your head, I strongly recommend the Kaggle time series course. It's got all these techniques we're going to be talking about are in great detail here. And especially this first notebook we're going to be going through, my notebook, all this stuff is just talked about explicitly in here. It's a really, really great course. Okay, so jumping into my notebook. Little thing to call it here, this little utility script. I just collect sort of functions as I'm going through in Kaggle, and they have this neat function that came out maybe a couple of years ago where you can call another notebook and just use the functions from that notebook. So like doing something like getting a summary of that, or doing like one-hot encoding, things like that. Things that I do frequently. I just keep collecting and putting in there, and it's kind of a useful thing that I have. So feel free to use that for yourself if you want. We're going to be using LightGBM. LightGBM is just kind of running away with the gradient boosted tree dominance these days. It seems to be way better than XGBoost and CatBoost. I've seen a number of grandmasters who prefer XGBoost, but LightGBM requires quite a bit less hyperparameter tuning, so that's why we're using it here. But XGBoost and CatBoost would be fine choices as well. They do very, very similar stuff. A big ensemble would actually probably be the best thing to do. Let's see. Okay, so let's just jump in. So little loop here to go through and read in all the data frames. So we're just kind of walking through the Kaggle input directory, reading them all in as data frames. So just looking at the tables below, right? So the training goes from January 13 to August, January 2013 to August, middle of August 27. So the test CSV is August. This just starts right after that, and we're just trying to predict the first 15 days of August. Transactions are all per store. The oil prices go all the way through the test period. So my little utility function here, you're seeing it. So this little info thing, it's just instead of calling dfed. Anyway, I like it. Use it or don't. All the stuff that we have. So holidays, right? So they give you a list of Estonian holidays. It makes a good feature. Oil prices on the day, sample submission, right? So the ID is you're just gonna pass the ID and then the number of sales. So if you look here, not at the stores, if you look at like the test, right? So we have an ID, so 3095, right? For store, it's gonna be store family for poultry, and then for the sample submission, we're just gonna say ID. This is the ID, and it's because it includes the date and like how many sales happen on that. Okay, so the training data frame, so notice that it's aggregated by the store number and the family of the product, right? So we're not trying to predict the difference between chicken thighs and chicken breasts getting sold. We're just, predicting the entire, how much sales that we had for poultry on that particular day. It wasn't on promotion, and that's all we kind of have in train and test set. So the sales, this is the Y column. So you'll notice that is missing from the test set. So it's the same thing. Let's see. Oh, stores data frames. Right. This is just reference data for the stores that will be joining for a feature. And I think that's it. I think we covered all the stuff there. Oh, and transactions. Oh, so right. So transactions is simply the raw number of count of transactions that happened in that store on that particular day. And as we're going down, so I just did a very, very quick EDA, just aggregating all the transactions across all stores. And the reason why, because I wanted to see what the seasonality looked like. And as you can see, right, there's, if you zoom in, can I zoom in on this one? Oh, I can't zoom in on this one. Oh, maybe I can. That's fine, actually. But you see, there's spikes up and down, like for weekly trend, right? More stuff gets sold on Friday, I believe. And a bit of a drop off on the weekend, and then kind of during the week is the spike up, and then there's this huge bunch of weirdness that happens around Christmas and New Year's, since we're only trying to predict, so there's a few ways to deal with this. So since the task here is only to predict the last 15 days of August of 2017. You can safely discard this, right? Because this is not going to be, this sort of spike up and down is not going to be effective. Is not going to affect the sales in August. Obviously, if you're making a model for the store to use for all time, you need to incorporate that time. But you could probably just even just build a separate model. If I were doing this for a store in real life, I would consider strongly just building a completely separate model just to deal with the last, the end of December going through like the beginning of January, because it just gets completely out of whack with the whole rest of everything. So you could just simply have a whole different class of models. And here, as you'll see as I kind of go down and show you some of these other features that I built, I excluded that stuff, and it greatly improved my score from a number of the features that I built. Okay, so this is just so I just aggregated the sales by family here. So a lot of zeros, right? So we have a lot of days that, for example, that no automotive sales will get sold in a particular store. And then you kind of have like this sort of just like gradual, this quick fall off, and then this like sort of, long tail here. I guess the point is this distribution is not a Poisson distribution. It's just kind of, I actually don't even know what to call this distribution, but it's good to have a look at it. Okay. Feature engineering, for my personal like cross validation, I just simply used, the last 15 days of August. This is kind of geared, like I mentioned, this isn't, you're not, you're just geared towards making a good predictions for the last 15 days of August. We're not building a model that's going to be used for the store for all time. So it's a pretty fine thing to do. Right. If I was doing this for real, right, I would have cross validation going from a whole bunch of different months, with doing that in the time series way, and meaning that in the time series way, you need to be careful about not by splitting your data based on date, right? So you want to take you want to take like 6 months of data, and then you want to try to predict the next 15 days after those 6 months, and then kind of moving along throughout time. Sliding the training and test set based on date. Okay, so then we're just doing so features we're making here. So calendar. So just simply just taking the date and just exploding that out into different columns. I'll show that in a second. what I mean there. So target and encoding the day of the week, which I'll show you down there, and then target encoding some holidays. Again, this might have not been useful because we're only trying to predict these days in August, so I could have maybe even cut that out. Okay, so exploding out the dates here. This is so just another thing in utility here. So just adding date part. So it just basically takes the date, and it's going to make a year column, a month column, and a day column, and things like that. So because you can't pass a date to a model, you have to have different columns that break out the date. National holiday. So I just added national holidays in here. I didn't add like all of the local holidays, which might have improved my score a little bit. So all right. So since we are calculating 15 days in advance, there are no moving averages that I used here. I actually tried to work that in, but it doesn't really work for something that you're trying to predict so many time steps out in the future. When you're doing a time series problem that you're trying to predict the very next time series, only the very next step in the time series. So like for example, we were just trying to predict what was going to happen tomorrow. Then we would be using moving averages, and we'd have like a 7-day moving average and a 3-day moving average and things like that. But that only makes sense for the first step in the series. So because we're trying to predict 15 days out, it doesn't make any sense. So I have lag features, just simple lag features, like what happened 7 days ago, 14 days ago, and 28 days ago. And because we have weekly trends, this is what I decided to do. I maybe could have done a whole bunch of other ones there, but I did have a whole bunch of other ones there, but they did not help my score and cross validation. Right. Okay, so just being careful here to make sure that I don't use anything that's from what I said as the cutoff date above, and then converting all right. So so another little utility function here. If anything that's an object, we're converting it to a category. Because LightGBM can just handle categories. If you're using XGBoost, you're going to have to do a whole bunch of other work here, but LightGBM just handles categories beautifully. Let's see. Okay, fine. Right. All right. So right here, we're just calling the functions. Yeah. And then just looking at those, looking at the manipulated data frames. Okay, now down here I have a different day of week target encoding, and the reason why that I split that out is because this function up here, right, the process, the data frame, all of the stuff that's happening in here will happen in the training and the test data frames. So all that stuff is going to be exactly the same. In day of week encoding, right, we're taking the this is called target encoding. So you're taking the target, and in this case we're taking the target of what happened, aggregating by the store and by the family in the day of the week. So we're going to take like poultry sales and automotive sales, for example, for store number 1 and also for store number 2, and we're going to aggregate everything that's happened on Monday, and we're going to build a feature for that. So we're going to say by average on Monday, this store sells 10 items of poultry and 1 item in the automotive family, and we're going to do that by everything. So the reason why we have to split that up between the test and the training data set is that we don't want to have data leakage, right? So we don't want to have the training data set to know anything that it shouldn't know. Meaning that, like, if you think about, you're trying to make a prediction for what's going to happen 15 days in the future. You shouldn't know, you're not going to know in production what's going to happen 15 days in the future. So you can't, get those averages. So we have to be very careful about about doing that. And then what this feature eventually does, right, is we'll be able to use all of that, all of the values that we've calculated the mean of, and just use it simply as a feature. So, right, so now we know. So like if you're trying to predict what's going to happen 15 days in the future, I know that on Monday, by average, I simply sell 10 units of chicken, 10 units of poultry, and so we can account for that, and we can use that as a feature, which is works very, very well. This is a very typical thing to do in not just time series, but in any sort of tabular data where you're doing target mean encoding. But anyway, point being is just be careful if you're going to be doing this to separate it out from your standard data frame processing and make a different function for that, so that you're dealing with that in a proper way, because we're just taking the result here, and we're going to be just merging that with the training set, the test. We're going to be merging that with the test set. Okay. Right. So just looking at taking a look at how that looks. So so the output here is the data frame. So seafood, for store 54 on day, on day of the week, on Monday, right, sells an average of 2.1, and Tuesday is 1.4, right? So this is a very useful feature. All right, so here we're just looking at. I just found it useful to just look at like one store, and here's all of the features that we built for this one store. So what happened 7 days ago. So we're looking again at like an individual family here. So store number 41. So produce. We're just looking at produce in store number 41. So on the 1st of July in 2017, 7 days ago, right, we sold this much and this much and this much, and then we have 28 days ago, and then we have the day of the week mean for poultry for whatever the day of the week that is, right? So all this stuff combined is all these are useful features that we can pass to our model. And then this day happened to be a holiday, so and then we're doing holiday target encodes. So same thing with day of the week holiday encodes. We're just simply aggregating by individual holidays. Okay, right. So so store 54 on Veneris Santo, they sell an average of 1.8 units of seafood. Okay, and pass all that to model. So here's what we're going to be passing to the model, and then some parameters. So I believe I ran this through Uptune. I can't actually remember if I used Uptune or not, just to simply find. Anyway, it's fine. It's reasonably average parameters. So we're not doing anything crazy here. And then simply pass it to the model. We have this is unnecessary here because I actually have. Sorry. So what I did here was let me go to my training log and kind of walk through what I did here. So just simply passing it to the as it was just produced a pretty terrible score for my cross validation. I guess the takeaway here is that machine learning is extremely iterative, and just you have a score and you're just trying different stuff and trying to figure out like what actually moves your score, what actually moves the needle on your score. So this notebook went through quite a few iterations to finally get to like a reasonable score. So just starting with nothing, starting with just like taking all the data as it was, I got a pretty terrible score. remove Christmas and day of week, moved it a little bit. The Tweety distribution, helped it a little bit because it knows to expect lots of zeros. Had a little bit of an error there when I was training with the IDs. That was kind of a dumb thing. Removed elapsed. Oh right, I had like just the time series. Sorry, not the time series. The function where I break up the dates. I had this like elapsed feature, meaning that like elapsed time is like time since like 1970. Got worse right when I removed actually remove month end. It actually is it actually turned out that those features were somewhat useful. So it just made the model train a little bit longer. And then bang, I figured out that just simply all of the older data was useless. So it actually was hurting my score quite a bit. So anything prior to 2016 was just making my score way worse for doing the target encoding that I was talking about, especially. So just simply just only taking the past year and a half for target encoding was what added a huge boost to the model. Right. So the best thing to do to kind of troubleshoot and figure out like where to go with your next steps is looking at feature importance. So light GBM and XGBoost and cat boost and random forest and pretty much any tree-based model is very, very easy to look at the feature importance. So this code goes through graphing that, but with Plotly. So, but the gist of it though is like sales 7 days ago is really, really important. It's just by far the running away with it. The day of week mean sales, once I like I mentioned, once I cut off cut it off to only the past year and a half, added a huge boost as well. 14 days ago, somewhat important, not too much important. 28 days ago, and these other features are less important, but still will affect the model in some way. So different ways of feature. So so gain, meaning like how much it improved the score, and then split is how many times that the model decided to use it in determining where it was going to split off the data. If you know how, don't have time in this video to explain how a decision tree works, but we're talking about splitting the decision trees. Right, and then we're just doing submits down here and like how to actually like process it and like process the training set. Basically, we're doing all the same stuff for the training set, we're doing all the same stuff for the test set that we were on the training set to make the submission. This is I'm going to skip over this because it's not particularly interesting because I want to get to. So this is my simple notebook that got a reasonably good score. Nothing to write home about. Just simply one model. Kind of doing all the basic time series stuff. Doing a bunch of iterations to kind of figure out what moved the score. We got a reasonably okay score that I'm not ashamed of, but I'm not particularly proud of. But then, so moving over here, this is a this notebook has this like is well at the top of the leaderboard of like 0.38 or 7 or something like that. And they so first of all, they're using this this really great library called Darts, and Darts is just geared towards doing time series analysis. I don't have time to get into like like how to set up Darts, but essentially you do all your data processing like you do in Pandas. And then I'm not going to go through this person's EDA, but I did some good EDA stuff. So I'm not going to. So you essentially set up like everything I did there in Pandas, and then you pass it to Darts is what they have their main unit of like data storage is called a Darts time series. And then the advantage there is that it handles all of the all of like the kind of annoying time series stuff that you would want to do to improve your model. So the big improvement here that this model makes from my model is that he made 33 different models for each product family. So so he's got one model for automotive sales and one model for poultry sales and et cetera, et cetera. And I'm sure you can guess how this would be useful for predicting, like, on, Christmas in the U.S., right? You're going to sell a lot more ham, for example. So this is just extremely, this is a very, very typical thing for time series for doing time series analysis, of figuring out an interesting way or useful way to bag your data, right? And this is and typically what you'll do is you'll make a different model for each bag of your data, and so this is what's done here. And Darts is just a way of facilitating doing that in an easy way. So and it just takes care of like so much stuff here. And the other great thing with Darts is you can just it takes all of your data and it will just pass it to a whole library of different models. So they have light GBM in there, LSTM in there, and hits these deep learning models. None of them were particularly useful in these in doing this. He pretty much just went with all light GBM. He's got all these quite a lot of EDA in this notebook. It's worth your time if you really want to learn how this stuff. Yeah, boosted trees, right? So this is boosted trees is what he's what he wound up doing here to win the day. Oops, I skipped past all of his code. Right. Right. Anyway, so that's so you'll learn about all that stuff in the time series course. But I strongly recommend going through how Darts works, and maybe. But yeah, the takeaway there is that Darts will aggregate all of your data, will aggregate all this stuff for you if you know how to work with it. Okay, I guess that concludes the video on basic time series. I hope you learned some stuff and found it somewhat interesting. And anyway, thanks so much for tuning in.